So students, welcome back to the channel. Where we try to make mathematics a bit more fun. Today we are once again going to be continuing for that our ITF series, trigonometric series. And today we will be focusing on solving a few problems. So the first problem we have been provided there is says that sin inverse of x plus tan inverse of 2 is 5 over 2. Now it's asking us what is the value of x here. Okay, so it's not very difficult. What we are going to do is we will have to transform either of these two inverse geometric operators, the geometric values actually, into something similar, like maybe turning this tan into sine, or maybe turning sine into tan. Either of the that will work, or maybe we will do that to like turning both into cos, and maybe after that what I'm going to do is you're going to apply formulas left or this. That this will tell us how to add two geometric functions. Okay. So let's try changing this sin inverse of x into tan inverse of x. So here height is so length is x and hypotenuse is 1. So this is going to be root over 1 over 1 minus x square. So you can write this as tan inverse of x over root over 1 minus x square plus tan inverse of 2. It's 5 over 2. Now we know what this would be. This would be tan inverse of x over root over 1 minus x square plus 2 over 1 minus 2x times root over 1 minus x square. Okay, this will be 5 over 2. Now we can apply tan function to both sides. So you can do it like tan of tan inverse of this thing, and right side you will have tan of 5 over 2. And what this tan function will do, this will cancel each other, because obviously we are talking about primary range values here, and tan is a function which can take values of infinity, because tan 5 over 2 is infinity and negative 5 over 2 is negative 2. So here both the domain and range are infinite, so we don't need to worry about anything here. This would just become like this, x over 1 minus x square is 2 over 1 minus 2x. Well, I think I missed root over root here. 2x over root over 1 minus x square. Tan pi over 2 is infinity. And then we will rewrite this as 1 over 0. Now what we are going to be doing is we are going to be multiplying both sides by the denominator here. So actually that won't work. What we're going to do is we're going to be changing sides here. So we can send this 1 minus 2x over x square this side, and this would multiply. This would multiply with 1 here, and this 0 would then be multiplied with this quantity, and that itself would become 0. I know that's not how things work here. We have to multiply both sides like same thing, but that seems a little bit difficult right now. Uh, we can actually do one thing here is that no, that won't work. We have to just switch sides here. So we would have is 1 minus 2x over root over 1 minus x square would be 0. So from this we get 2x over root over 1 minus x square is x, is 1. So from here we get is 2x equals root over 1 minus x square. Squaring both sides, we would get 4x square equals 1 minus x square, or we can add x square to both sides. Plus x square, and this 2 x square we cancel out each other. These two would add up. X square first will add up. We have 5x square equals 1. Now we can divide both sides by 5. So we have 5 and 5 will cancel out each other, and we will be left with just x square on the left side of the equation, and right side we have 1 over 5. Now we can take square root sum of both sides. And here this root and square root cancel each other. We will have just left with x, and on the right side we would have root over 1 over 5. Root over 1, I mean root of is of course going to apply to both the numerator and the denominator. So we have root over 1 over root over 5. Root 1 is just 1. So the final answer is x equals root over 1 over root 5. Okay. Now the next problem, let's go to that. What is the next question? Let me find a difficult one. Yeah, let's do this one. It's a spot of sine inverse of 1 over root 5 plus sine inverse of 2 over root 5. When I asked to evaluate this expression, we got some answers here. This is going to be fun. So first of all, we don't want to remember this chord formula. We can do that. I mean, we can do that by taking the reciprocal of tan of a plus b formula, but that's gonna be a bit problematic. Instead, I mean, we can go that way, but the approach I'm gonna be going with involves doing us this. So first of all, this is the chord trigonometric operator, and we have sums of two angles inside of it. Basically, I can say that this sum is theta. So what we actually have is cot theta. So now cot theta can be written as reciprocal of tan theta, tan of this thing, that is sine inverse of 1 over root 5 plus sine inverse of 2 over root 5. Okay. Again, it is using the trigonometric identities. I mean, inverse trigonometric representation actually. They will be called. This can be rewritten as first of all we know that uh, the length is 1, and we know that let's say the base is x. So let's say the base is b. We know that the length is 1 and the base is b, and we know that the hypotenuse is root 5. So we know according to Pythagoras theorem, uh, root 5 would be equal to root of 1 square plus b square. Now taking squares of both sides, you would have 1 square plus b square equals 5, or b square equals 1 square is just 1. Subtracting 1 from both sides, we would have b square equals 4. Then we are going to taking roots of both sides. So b square would become b would be root over 4, that is plus minus 2. Now we are going to be taking only the positive side over here, because at the end of the day this is nothing but uh, the base of a triangle, basically length, and a length can never be negative. I mean, yeah, you can definitely play around with its direction, but its magnitude can never be negative. And secondly, in trigonometry, when you are trying to find out the trigonometric ratios for different angle values, we are only manipulating with the directions of the hypotenuse and the height. We just leave base as it is. So base just never becomes negative. It would be just 2. So we can write this as tan inverse of 2 here, and tan inverse of 1 over 2 actually, and over here we know that the height is 2, and again applying this formula, let's say we know that height is 2 and the base is going to, let's say call it b again using this formula. We know that root over 2 square plus root over b plus b square would give us root over 5. Now taking squares of both sides, we would have 4 plus b square equals 5. Now adding minus 4 to both sides, you would get b square equals 1. And now taking roots of both sides, we would have b equals plus minus 1. Again, we are going to only taking plus version, the positive one. Okay, now this times length is 2 and this is 1, so we would have tan inverse of 2 over 1, that is just tan inverse of 2. Okay, now we can apply the tan of tan inverse. Basically, we can apply what we can apply here is tan inverse of a plus tan inverse of that identity. So it will just become 1 over tan of, you know what this is gonna become? This is gonna become tan inverse of half plus 2. If you guys are wondering what is going on here, you can check out my previous videos on this series. I've thoroughly explained why things are happening the way they are right now. That's why I'm going a bit fast. Sorry if you think that I'm going a bit fast. Tan on the remainder, we would have 1 minus half times 2. Now this 2 and this 2 will cancel out each other, and we'll be left with this 1, just 1. Now we have positive 1, negative 1, so this 2 would add up to become 0. So inside of this, what we have is 0, and anything over 0 is undefined or infinity. This time we have positive infinity. And why, you might say that why is would this be positive infinity and not negative infinity? Because what we have in the numerator is positive. If we had something negative in the numerator, then it would have been uh, negative infinity. But since numerator is positive, we would have positive infinity here. Now tan inverse of positive infinity. This is we know that tan of pi over 2 is infinity. So of course tan inverse of infinity positive infinity would be pi over 2. So this can be rewritten as pi over 2. What I actually do here is uh, we have tan inverse of infinity. So this tan and tan would cancel each other, and again because both tan and tan inverse have domains are ranging from minus infinity to positive infinity. So you don't need to worry about anything here. This would just become infinity because this tan and this tan inverse would cancel each other. This would just become infinity, and what we have here is 1 over infinity. So remember this rule: any real number over 0 is infinity. The same way, what I can do here is you can send the 0 to this side and bring this infinity to this side. You would have 1 over infinity equals 0. 1 represents any real number here. So you have a real number over infinity, so that will become 0. Okay, the solution of this problem is answer is 0. Okay, now one major thing that I should clarify is that why is tan of pi over 2 is infinity. I have always been a great advocate of learning the why in mathematics. Why things are happening there. You don't need to memorize all the formulas. You don't need to memorize all the alternatives. You don't need to memorize all the values. But what I think is absolutely necessary is your understanding why things are happening the way they are. So trigonometry is again about right angle triangles. So let's have a right angle triangle here. ABC, whose angle C is theta. Now tan theta could give us the ratio of the length of the base from the perspective of this theta, this angle theta. We know that the side on the opposite of this angle would be the length, and the side on its adjacent side would be the base. So tan theta here would be AB over BC. Now let's say the value of theta here is pi over 2, that is 90 degrees, pi over 2 radians, that would be 90 degrees. So that means this line is going to be perpendicular on this line BC. Now we have a geometric shape. It's not yet a shape, it's not a shape yet, which has two right angles. So these two lines, first of all, these two lines, AB and this line here is both are perpendiculars onto a single straight line. So that means these two are gonna be parallel to each other. So that means we won't be able to form a triangle here. The only way we would be able to form a triangle here would be if somehow we could make these two sides intersect. And you can see that making that happen is going to be very difficult because these two are parallel to each other. So what we can do here is we can take these two sides to infinity and then expect that these two would intersect with each other. Because I know it's at the end of the day it's an assumption because but Mathematics is built on assumptions anyway. Mathematics is just full of assumptions. If you don't believe my words, you can check it out. You can check out my old videos about calculus. Calculus is just totally based on assumptions. Okay, so we can say that if two lines are parallel to each other and they go on and like that until infinity, they are intersect with each other. So let's say there is a point that is to meet intersect and the point is infinity. So this means the length of both of these sides would be infinity. That means we would be able to form a triangle here, a right angle triangle indeed, because at least one of its angle is right angle. But the thing here is that it's both its hypotenuse and height are infinity, and tan function over this angle theta, which now has the value of pi over 2, gives us the ratio of the length of the triangle, the height of the triangle actually, over its base. So the value of theta is pi over 2 right now. Pi over 2 radians or 90 degrees radians. Pi over 2. And now a point would actually exist here because a is the point where the height and the hypotenuse intersect with each other. So now tan pi over 2 is AB over BC, and AB, since both of these lines have length of infinity, so the value of AB is of course also going to be infinity. It is infinity, and BC has some real value. Regardless of any real value it has, it is gonna be infinity, because just imagine, let's visualize this. We have infinity here, and we are going to be dividing it by a real number. Let's say r. Now, no matter how many times we subtract r from infinity, we would be left with infinity, because infinity is supposedly a number which never ends. So, of course, this is just gonna turn into infinity. No matter how many times we subtract something from it, the division is at the end of the day multiple subtractions, successive subtractions actually. But we're now left with infinity anyway. So this is why tan pi over 2 is infinity. So this means this is where this formula comes across. This formula we're going to be derived from. This identity that tan inverse of infinity is pi over 2. Because when we plug in pi over 2 in the 10th function, we get infinity. Okay? So then this is where I would like to wrap this session up. If you guys think that you have any doubts regarding anything I have told you today, you can let me know about that in the comment section. I'll definitely try to resolve your doubts. And until then, keep learning.